Welcome to our Mathcast on Slope-Intercept form.
Our goal is to help you better understand the concepts at hand, when you need it, and at your own pace.
We hope you enjoy this Mathcast on Slope-Intercept form.
Okay, the slope-intercept form equation is y equals mx plus b. The x and the y value in this equation represent the x and the y in an ordered pair. The m represents the slope of a line. B stands for the y-intercept. The y-intercept is where a line intercepts with the y-axis.
Now let's use the slope-intercept equation to make a graph. For this equation, 2 over 1 is the slope, or m, which is attached to x, and 1 is the y-intercept, or b, as we learned. Let's mark the y-intercept on the graph with a point. Now take the slope. Since it is positive, this graph has a positive slope. Go up 2 and right 1 from the y-intercept, because up 2 and right 1 is the slope. Do that again. Now let's go back the other way. Start at the y-intercept again. Go down 2 and left 1 and mark that with a point. Do that again. Now you may be thinking, hey, down 2 and left 1 isn't the same as up 2 and right 1, but it really is. The first time our slope was positive 2 over positive 1. Then it was negative 2 over negative 1. But our slope really didn't change since 2 negatives equals a positive. Now we have to connect the dots to make a line. Since 2 over 5 is a point on the line, it is a possible solution.
This equation looks a bit shorter than the previous one, the J graph. You may have noticed that is missing the B value. What do? Is this equation just impossible to graph? No. When the B value isn't there, it represents 0. Since you want everything in simplest form, putting a plus 0 at the end is pointless. But if you want, I guess, you could put it there. So the y-intercept is 0, 0, or the origin. The slope is negative 1/2. So we go down 1 because it is negative and right 2. Why don't we go down 1 and left 2? The slope is negative, right? Well, if you subtract a negative, it is equivalent to adding a positive, so only one of the values are negative. If they were both negative, then we would have positive slope, like Jay explained in the last problem. So, back to the graph. We start at the origin, go down 1 and left 2 points from there. Then we do that again, and again. Now, like the previous example, we need to go to the other way. So we start at the origin and go up 1 and left 2. That makes the left 2 makes the slope negative. Do that twice more and connect the dots. And then we're done.
This equation isn't in slope-intercept form, therefore we can't graph it yet. We have to change it to slope-intercept form. To do that, we have to get the y variable alone. We have first subtract 3x from both sides, so that your new equation is 9y equals 18 minus 3x. Next, we have to divide 9 from both sides, so that your new equation is y equals negative 1/3 x plus 2.
Please excuse this interruption. At
2 is the y-intercept, so we can put a point at 0, 2. Now go down 1 and right 3 because the slope is -1 and +3. Mark that with a point. Do that again. Now go back to our y-intercept. Go left 3 and up 1 now. Mark that with a point. Now do that again. Next, connect all the points, and that is the graph. Yay! You can see here 2 different lines. These lines, although the equations are similar to slope-intercept form, are not slope-intercept form. The line that looks like a U is called a quadratic function. You get this line when one of the x or y values has an exponent, an even exponent. The one that looks like a weird squiggle is called a cubic function. You get this when the x or y has an odd exponent that is above 1. So like 3, 5, 7, etc. Slope-intercept form is only used to graph linear functions, so these are not slope-intercept form.
Okay, now for some real-life application. Yay! This is where you learn when you can actually use this stuff. This problem reads, a freight company charges $22 plus $3.50 per pound to ship an item that weighs N pounds. Write the information in slope-intercept form and then graph up to 100 pounds. Okay, so we want to set up an equation in slope-intercept form. So C, or everything must be equal to the cost. So we will put C equals to represent that. Then we have the initial cost of $22. So we will write $22 on the opposite side of the equation. But then we can't forget about the $3.50 cost per pound. Remember that our package weighs N pounds. So we will write 3.5 N to say that our package costs $3.50 per pound. Our final equation is C equals 3.5 N plus 22.
Okay, that's pretty good.
Okay, great. We've got our equation. Now we have to graph it. First, we have to set up our graph. Since you can't have negative costs, we will only focus on the first quadrant. We'll set up our weight as 0, 25, 50, 75, and 100, such that it only tells us to go up, to graph up to 100 pounds. And then our cost will be up to 400, going up in intervals of 20. We have to start at 22, since 22 is the initial cost. It's the y-intercept, so that's where we start. Let's put a point around there. Then, with every pound, we'll go up 3.5 for the cost. But that will take a while to graph, so we'll go up in intervals of 20 pounds. For 20, we'll have 20 for the cost, and then 82, or 20 for the weight, and then 82 for the cost. Then we have 40 for the weight, and 162 for the cost. Then we have 60 for the weight, and then 232 for the cost. Then we have 80 for the weight, 80 pounds, and 302 for the cost. And then finally we have 100 pounds for our weight and $372 for the cost. We will have our line And then we're done.
Thank you for listening to this Mathcast on Slope-Intercept form.
Please feel free to listen and learn from other Mathcasts on this channel.